Well, if you are going on to pre-calculus, this might be something that would be of interest. It's not in our curriculum and it gets a little bit tedious, so I will not do this one, but it deals with the distance formula, the midpoint formula, and the distance formula is just for definition's sake, if you are doing a graph and on the graph you have, let's say, this point and this point, and you want to know the length of that line, that is the distance formula. And you would use a modification of this, which is c squared equals a squared plus b squared. And then you take the square root of that and the square root of that, so you get distance equals the square root of this, which is, as I recall, x sub 2 minus x sub 1, the quantity squared, plus y sub 2 minus y sub 1, the quantity squared. And if you have the coordinates of these points, that's how you get the distance formula. Now, the midpoint formula, you're looking for this point right here, that's midway between that, and that would be an x and a y. And basically the midpoint formula is x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. That will give you the midpoint that you list then as an ordered pair. So a very short 2.5 minute summary of this without doing any examples. We will not have any on the test or on the final. Okay, our last topic in chapter 7 will be complex numbers. Now, what is a complex number? Well, so far in our textbook, we have been saying that the square root of a negative number is not a real number. In this section, we will be defining a new set of numbers in which we define the square root of -1 as the letter I. And if we square both sides, we get -1 equals I squared. So we are defining this as a new number. Now, initially when this was done many years ago, they called it an imaginary number, and that's where the letter I comes in. It's not imaginary, it's just not a real number. And then these numbers that we will call imaginary, just to give them a name, along with real numbers, form a big new group now called complex numbers. So that's what they're talking about here. So how do we work with them? And I will be going over the rules with you and looking at our examples to do so. So we have in the first case, and these are worked out down here, but let's do them from up here. Now often what we do is we tease this apart into the square root of -1 times the square root of 7. Now we're defining the square root of -1 as I, So in simplifying this, this just becomes I, the square root of 7. Or you can also write it as the square root of 7I, being careful not to include the I under the radical sign. So again, mentally you can take out the I from here, right? Because that's the square root of -1 times the square root of 16. Take out the I, and this just becomes 4I. Now here you're taking out the I, so that would be -I, the square root of 13. Okay? And now we have this one that I'll work over here for you. Now we had in an earlier section, let's take out the I, and now we had that as the square root of 25 and the square root of 2 as we simplify that, factoring it into one that is a perfect square. So the square root of 25 is 5, so we usually write this as -5, then we put the I, and then the square root of 2. And again, you can always put the I afterwards as well. This way is preferred because you don't run the risk of putting the I under the radical sign. Okay, so an imaginary number is a number that can be written in the form, and by the way, there is a standard form for complex numbers, A plus BI, where A is a real number, this is an imaginary, and together they make a complex. So reading this over is probably a good idea to give you solid background. So here in writing complex numbers, you would write it in the form A plus BI, a real number, imaginary number, a real number, imaginary number, a real number, sort of, and imaginary. That's why theoretically, you should have the I afterwards, but they make that exception. These are all complex numbers. And in a sense, since these are factors, this is the imaginary part, and the A would be actually a 0, since there isn't a real number there. Okay, let's go on. Now, in dealing with complex numbers, we can think of the I as if it were a variable, which it's just a letter, but whenever you get I squared, you have to convert that to a -1. So let's go ahead and take a look at some of this here. So the following are examples of complex numbers. And these are all complex numbers. This side is imaginary, this side is real. Going back to our chapter 1 stuff. These are pure imaginary, and these are complex, since they're a combination of real and imaginary. And we had the irrational, you remember, and rational. And then note that though the square root of -7 and the cube root of -7 are both complex numbers, it's only when it's an index number that's even is it imaginary. Okay, now when we add and subtract, what goes on here is treat it just as it would be a letter variable. So we're going to combine like terms. This will give us an 11, and this gives us a plus 8i. And we write it in that form, a plus bi. If you put it in a math lab a different way, they're going to count it wrong. Now when we subtract, again, first let's get the sign straight. Here we have to reverse this sign. That's going to become a negative. And we reverse that sign. That becomes a positive. And we group like terms. So that'll be a negative 2. And this will be a plus 8i. And we leave it in complex number form. All right, doing some of the others. We're now going on to multiplication. Now, here's where it gets a little tricky. You might think that here you would just get a negative times a negative, a positive, the square root of 10. That would be incorrect when you are dealing with complex numbers. You have to treat it this way. I, the square root of 2, times I, take out the I first, the square root of 5. Now, I times I is I squared, the square root of 10. Now, what did we say I squared was? Well, we said that I squared is a negative 1. So this then becomes a negative 1, that we don't write the 1, the negative square root of 10. Now notice if you did it the old-fashioned way, you would get a positive 10. But in complex numbers, you have to do it this way. So to bring out the negative, the I squares that become a negative 1, have to do it this way. And they're giving you that caution here as well. And write the answer in complex number standard form. So here, this is going to be I 2 times I 5, which gives you I squared 25, which gives you a negative 25. Well, how about 10, huh? Wow, what am I thinking of here? Senior slip? How about 2 times 5? I'm thinking 5 squared. 2 times 5 is 10. Negative 10, yeah. And you might say, Mr. Paulin. Okay, let's go on to the second one here. Again, this is going to be I, the square root of 5, times I, the square root of 7. It's Christmas morning actually today when I'm doing this, and I'm catching up. So that one would have become a negative 35. All right, for letter C, now this one's already in a nice form. Since the i's are there, this will be a negative 24 I squared, but I squared is a negative 1, so this becomes a positive 24, as we see down there. And letter C, we did. Letter D, now we didn't do these with radicals before officially, but we're going to take a look at it now. We're going to distribute that and get a negative 12i. Distribute that and get a positive 20i squared. Again, if you put that in the math lab, they're going to count it wrong because I squared is a negative 1. So you write the negative 20, that'll change this to a negative 20, minus 12i, which is now in the form a plus bi. And that's what they're looking for. So let's just raise that up so we can see it. Okay, so there's what we got. There's the negative 20, but you have to put it in standard form. And then now we're going to FOIL this one. This times this is 4. Our outers are a positive 3i. Our inners a positive 8i. And our last a positive 6i squared. But we know that I squared is a negative 1, so this is going to become a negative 6. A negative 6 and a positive 4 give you a negative 2. Adding these together, you get a plus 11i. And it checks. I love it when it checks. And I'm sure you do too when you put your work in MathLab, as I get a kick out of getting the right answer. It's like a little pat on the back, isn't it? Okay. Now, conjugates and division. So when we are dealing with division and we're trying to convert complex numbers, or what we have, an example, into a complex number in standard form, we have to take the imaginary numbers out of the denominator. Now to do this, we use what is called, again our old friend, hopefully, the conjugate. And these are called complex conjugates. Okay? So here, this would be the 1, and there is its conjugate. The same terms, opposite sign. Okay? So find the conjugates. Again, it would be a negative 3, but now opposite sign, plus 7i. Now here it's just going to be a negative 4i, opposite signs. Okay, and then now we're going to practice multiplying conjugates. When you do, again, the middle terms cancel out, but often what happens, when you square the I, you get an I squared, which is a negative 1, which reverses this sign from negative to positive. And we end up with this from multiplying conjugates. So let's take a look at a division now, and I will write this out for you. So we have a negative 5 plus 9i over 1 minus 2i. So what will the conjugate be? Remember, we can multiply anything by a 1. And a 1 is anything divided by itself, so long as it's not a 0. So we're going to use this conjugate, 1 plus 2i, 1 plus 2i. And let's do our denominator first. 1 times 1 is 1. A negative 2i times a positive 2i is a negative 4i squared. But what did we say I squared was? A negative 1. So a negative 4 times a negative 1 makes this a positive 4. So our denominator now is 5. Now we have to FOIL the top. So we get a negative 5. Now when we do our outers, we get a negative 10i. Our inners a positive 9, so that's going to leave us with a negative I all by itself. I'm doing that mentally, and this gives me a positive 18i squared. But what is I squared? I squared is a negative 1, so this is going to become a negative 18. Let me just save a little room here. You saw what I did. This now becomes a negative 18. So now I have a negative 5 and a negative 18. That will add up to a negative 23 minus I. And you might say, well, that's my answer. Yes, but if you put it in math lab, they're going to count it wrong because it's not in the form A plus BI. So we do that by putting the 5 under here, the 5 under there, and we can put our negative sign there. I have to do some more erasing here. I'm going to make that a positive. Put the negative sign between them and make that, in a sense, a positive that we don't write. So there is our answer in standard form, and we've used the conjugate to get our imaginary number in the denominator to make it a real number. Okay. Oh, I may not have recorded all that I had here. So let me go back to be sure I have included that. It was this one here. Okay. So what we said we were going to do here, so I think I had it on pause. That phone call came in and messed me up a little bit. Okay, so we had 7 plus 3i over 5i. And I'm saying the conjugate of this is a negative I. So that we do our denominator, this becomes a negative 5i squared, which a negative 5i squared, the I squared is negative, so this is going to become a positive. And I did this already, but I'm doing it again. And then doing our top, that gives us a negative 7i. And this gives us a negative 3i squared. But I squared is a negative 1. So this is going to become a positive. And I will erase that there. And to put it in standard form, I now get the 3/5, which is this one, minus the 7i over 5, which is this one that I have to put in the standard form, a plus bi. Okay. Now, when they did it a little differently. I like to use this as the conjugate. Remember, negative I over negative I is 1, and that allows me to get a positive term in my denominator. Here they ended up with a negative term, which nobody likes. Okay. Now, powers of I, and I will set that up. So a little background of powers of I. We know that I equals I, and I squared equals -1. Well, I to the third, can you see, is I to the second, which is a -1, times I, which equals a -I. And I to the fourth is I squared, which is a -1, times I squared, which is a -1. -1 times -1 equals a +1. Okay? So we have, in a sense, from powers of 1, from the first to the fourth, that they create a pattern. So when we go to I to the fifth, that is equal to I to the fourth times I. And then I to the sixth equals I to the fourth times I to the second. And I to the seventh equals I to the fourth times I to the third. And I to the eighth equals I to the fourth times I to the fourth. Well, all of these I to the fourths are a 1. Over here, this is going to be I. This is going to be a -1. This is going to be a -I. And this is going to be a +1. So it repeats this pattern every time you have I to the fourth. So when you are dealing with powers of I, what you want to do is sort of take out any I to the fourths that you can, and then you're left with something, and then it's going to be one of these. So let's take a look at what we have then, and see our strategy. And mine might be a little different than what's there, but whatever works for you. So we have I to the 18th. Now, what multiple of 4 is up in there? Well, that equals I to the 16th times I to the second. And I to the 16th is I to the fourth 4 times. So this is going to be a 1. This is going to be a -1. So I to the 18th is a -1, which is what they have right here. Now, in I to the 24th, notice this is divisible and it goes even. 4 goes into there even. So this is just going to be a 1, because this is I to the fourth raised to the sixth, which is a 1, raised to the sixth, which is a 1. Okay? And that's what they have worked out for you here. Let's try I to the 75th. Now, I to the 75th, they work it out a little differently than what I would do. I want to say, how many times does 4 go in there? Well, 4 goes into there once, and 4, you have a 3 left over. 4 times 8 is 32, and a 3 left over. So this becomes that as a mixed number. So all of this is I to the fourth times 18, which is a 1. And then you have this left over, which will be I to the third. Well, 1 times I to the third, you might recall I to the third is negative I. So that's the way I would do it, and hopefully you can see it that way too. Let's go on and see what else they have for us. Okay. They're giving us a little bit of work here, and you'll be doing your practice and your quiz-mes as you go for mastery. Remember, we're going to test. I'll probably give you the little test review. Well, the test review is done. I'll give you the review that they put here in our textbook. But I think that's all I'm going to do for today, and we'll pick this up after Christmas.